Mathematical inductions. Mathematical induction. So we have the steps in proving mathematical induction. So mathematical induction is one way of proving. So there are many ways, but one is mathematical induction. So for the steps of mathematical induction, we have the first one, prove true for n is equal to 1. Second step is assume true for n is equal to k. And third, prove true for n is equal to k plus 1. Now, the notion for mathematical induction is if p of 1 is true and p of 2 is also true, p of 3 is also true, then p of 5, p of 6, p of 7, until to p of n are all true. So just like a domino that when it starts to fall down in the first one, it will all fall up to the last stage. So example, we have here the first one. Prove that all positive integers n is in the form of this equation. So we have 1 plus 3 plus 5 up to 2n minus 1 is equal to n squared. So just like 1 plus 3, that is n squared. So that is 2 squared, that will give us 4. 1 plus 3 plus 5. So we have 1, 2, 3. So 1 plus 3 plus 5, that is equal to 3 squared, that is 9. Okay, so for the solution of this one, let us do the steps in mathematical induction. So first is prove true for n is equal to 1. So p of 1 is true since once we substitute it in the first equation, 2n minus 1. So we have 2 times 1 minus 1 is equal to 1 squared. So simplifying, so we have 2 times 1 is 2 minus 1 is equal to 1. So we have now 1 is equal to 1. Second step is assume true for n is equal to k. So what we are just going to do here is to substitute k in the value of n. So our equation is 1 plus 3 plus 5 up to 2 times k minus 1 is equal to k squared. In other words, we are just changing n. So there are no further steps here. Third step, this involves now the solution. So prove true for n is equal to k plus 1. So we are going to change n by k plus 1. So we have 1 plus 3 plus 5 up to 2 times k plus 1 minus 1 is equal to k plus 1 squared. So here, simplify, we have 1 plus 3 plus 5. 2 times k is 2k. 2 times 1 is 2 minus 1, that is plus 1 is equal to k plus 1 squared. So we simplify this one. So we have two methods, although there are different ways in which you can solve this one as long as you're not going to negate the operations or there are no violations of operations. So remember the principles of mathematics that you're going to apply in here. So for the first method, we use the assumption 1 plus 3 plus 5 up to 2k minus 1 is equal to k squared. This is the same as the assumption. Step number 2. So what we did here is to add uh, k plus 1. So 2 times k plus 1 minus 1. So once we add it on this side, we also add it on the right side. So we have 2 times k plus 1 minus 1. So getting now the sum of this one, we will then simplify the right side. So simplify the right side if we can arrive at k plus 1, the quantity squared. So simplify, we have k squared plus 2k plus 2 minus 1. So what I'm simplifying is the right side here. So k squared, 2 times k, 2 times 1 is 2. Then we have minus 1. Combine like terms, we have k squared plus 2k plus 1. Since 2 minus 1 is 1. Factor it out, we have k plus 1 times k plus 1. It will give us the same as k plus 1, the quantity squared. So since we already produce now the k plus 1 squared on this side, thus we have proven that 1 plus a 3 plus 5 up to 2 times n minus 1 is equal to n squared. So this is the method 1. Method 2. For method 2, we still use the combination of the assumption as well as the step number 3. So here, 1 plus 3 plus 5 plus up to 2k minus 1, that is actually the assumption here. That is equivalent to k squared. And then we copy now 2k plus 1 here. So 2k plus 1 equals k plus 1, the quantity squared, which is the right side. So our goal here is to simplify this left side to produce now the right side. So simplify this one, we have k squared plus 2k plus 1. When we factor it out, we have k plus 1 times k plus 1. So equals still to the right side because we are simplifying the left side. So k plus 1 and k plus 1, that can be written as k plus 1, the quantity squared, is equal to k plus 1. So we already equate the equations of both sides. So since they are equal, both sides are equal, therefore we can conclude, therefore we have shown that 1 plus a 3 plus 5 up to 2n minus 1 is equal to n squared. Prove that for any positive integer n is 1 plus a 2 plus a 3 up to n is equal to n times n plus 1 divided by 2. So this means that if we're going to add the first 3 terms, so 1 plus 2 plus a 3, that is equal to 6. Here, if we use this formula as well, so we have 3 terms here, so 3 times 3 plus 1, that is 4 times 3, that is equal to 12 divided by 2, that is 6, which is the same as the sum of the first 3 terms. Now, you can also do it as much as number of as you want. So here is the solution for the mathematical induction. Prove true for n is equal to 1. So we're going to use P of 1 is true since 1 is equal to, so substitute n for 1. So we have 1. Then substitute n by 1. So 1 times 1 plus 1 is equal to 2 divided by 2. That is simply 1 is equal to 1. Second step, assume true for n is equal to k. So 1 plus 2 plus 3 up to k is equal to k times k plus 1 divided by 2. Now, take note for the assumption because this is very useful for the third step. So, prove true for n is equal to k plus 1. So, here we just substitute 1 plus 2 plus 3 plus up to, since we already changed n by k plus 1, that is k plus 1, is equal to k plus 1 times k plus 1 plus 1 divided by 2. So we can simplify this one using the same method that we used a while ago. Method 1, here, what we did is just add k plus 1 on both sides for the assumption. So, 1 plus 2 plus 3 up to k, that is our assumption, plus k plus 1, ito yung inad natin. While on the other side, we have k times k plus 1 divided by 2. Now, we add k plus 1 on the left side, so we also do it on the right side and solve so that we can arrive at n times n plus 1 divided by 2. So, simplify the right side. We simply get the LCD. So, the LCD of 2 and 1, that is 2. So, 2 divided by 2 is 1 times k plus 1, that is simply k times k plus 1, plus 2 divided by 1, that is 2. So, here 2 times the numerator, we have k plus 1. Simplify the numerator, we have k squared plus k times 1 is k, plus 2 times k is 2k, plus 2 times 1 is 2. Then combine like terms, we have k squared plus 3k plus 2 divided by 2. Apply factoring. The factors of k squared plus 3k plus 2 is k plus 1 times k plus 2 divided by 2. So, k plus 1 can be carried over, but k plus 2, that is equivalent to k plus 1 plus 1. So, notice that k plus 1 is equal to n, and k plus 1 plus 1 is equal to n plus 1. So, divided by the denominator. So, since we already arrive at n times n plus 1 divided by 2, we can conclude now that thus we have 1 plus 2 plus 3 up to n is equal to n times n plus 1.